Hi everyone, and welcome to another live episode of Elektor Engineering Insights. I'm your host, Brian Tristam Williams, and we're glad to have you with us for EEI number 51. Today, I'm joined by Eddie Aho, the veteran power electronics engineer behind the KISS Analog YouTube channel. Eddie, how are you? I'm joined by Eddie Aho, the veteran power electronics engineer behind the KISS Analog YouTube channel. Eddie, we're getting an echo there.
Aho, the veteran power electronics engineer behind the KISS Analog.
Hi, sorry about that. I was hearing an echo.
Yeah, me too.
Yeah, Brian.
Oh, that's better.
It's actually an honor to be on your show here.
Yeah.
I've seen your magazines for years. It's
great. Yeah. We go back a long time as well. Do you have any headphones with you, Eddie?
It's great. Yeah. We go back a long time as well. Do you have any headphones with you, Eddie?
I am getting that echo. Let me see if I can solve that.
Well, put some headphones on. I'm just going to put Eddie on mute at the moment. He's having some echo issues. But let me tell you about Eddie. He brings decades of experience from aerospace, defense, and consumer electronics to his educational content. If you watched his YouTube channel, you know he's not afraid to tackle real-world amplifier testing, reverse engineer circuit boards, and cut through audio engineering myths with actual measurements. We're diving into power supply design, THD testing, and what it takes to make serious electronics accessible online. But first, let me tell you about our giveaway. We love to share cool tech, and we've got a giveaway running during today's show. One lucky viewer will win the Elektor Audio DSP FX processor, an ESP and ADAU1701-based development board that's perfect for guitar pedals, synths, audio effects, and DSP projects. Just keep watching. We'll reveal code word later in the show, as always, and you can enter it on the Elektor website for a chance to win. Eddie, you've got headphones on. That's great. I think the echo problem should probably be resolved now. Can you hear me?
I can hear you. I'm still getting
Correct.
echo problems. So I'm gonna.
Do you have another window open, maybe with the show on it? That's happened to me before.
I may have.
Okay, you look for that, and I will get back to our sponsor, Studium Travel. Sorry, Eddie. You're doing okay?
Yeah, I'm back. Yeah, echo's gone.
And you can hear me?
You're right. I had two windows.
Okay, great. Yeah, it happened to me once. I had no idea what was going on, and it's just one of those follies of live TV. But I'm going to tell the audience now about our sponsor. Now that we're fixed, because our sponsor is central to fixing things, our sponsor is DigiKey. DigiKey is the global leader and continuous innovator in the cutting-edge commerce distribution of electronic components and automation products worldwide. We get technical by providing more than 15 million components from over 3,000 quality name brand manufacturers with an industry-leading breadth and depth of product in stock and available for immediate shipment. So DigiKey supports engineers, designers, builders, and procurement professionals with a wealth of digital solutions, frictionless interactions, and tools to make their jobs more efficient. So thank you, DigiKey. We've got a €25 show here, and it's free to our audience, thanks to DigiKey. Okay, into the show. Let's get into it. I'm so glad that echo is gone.
Yes.
Let's start with your journey from aerospace and defense into creating educational YouTube content. How did that begin?
Yeah, I started in aerospace when I was in college, California, and worked at Aerostronics. So it was a great way to start a career. But I'm actually still working in defense, so still doing it. But I thought I was going to start doing some contract work on the side, set up a bench, and started doing what everybody else does. Looked at YouTube to see what the latest was on oscilloscopes. And then I just kind of started thinking like, hey, why don't I do a channel and show my projects? And so that's kind of how it started. And
Great.
I've always liked mentoring and, helping others. And so it just seemed like a good fit.
Well, it is a good fit. I've watched a lot of your content and everything from audio. I learned the difference between Class A, Class AB, Class D amplifiers, the digital switching, and that's all been very interesting for me.
Oh, great.
Are you a big music lover? I see a speaker there.
Yeah. I put that on the bench so I could, mostly do testing with it. But I've got another speaker around the corner that I listen to when I'm in here. And so,
Just one?
Well, it's a Sonos. Yeah.
Oh, okay.
I mean, in the lab, I actually bought some bookshelves to put back here. But as you can see, I don't have a lot of space.
Yeah.
So I need to clean up my bench. That's going to be a job I'm going to work on this year.
Well, I've got, a couple of Home Assistant pods, and I wasn't happy that they're mono. But then I bought stereo ones, the ones with the screens. What difference does it make? They're this far apart. Back in the day, we used to have stereo system.
Right.
But I guess I'm getting older. I probably can't hear much past 12 kilohertz. So what am I complaining about?
Yeah, exactly. Yeah, with that speaker, I can put test tones back here. And actually on the one device here has a speaker built in, and I put my ear right next to it, and about 12K. I think, I don't know if I'm trying to tell myself I'm hearing something or if I actually hear it.
Well, there's an app that you get on phones, which plays very high frequency sound, and you and I cannot hear it, but it really annoys the kids. They're like, stop that.
That's great. No, it's been fun. It's a lot of different types of projects, and if I didn't work, different, if I had a day job, then yeah, I spend all the time in this lab when I'm home. So, I'd have a lot more time for projects because I've got just tons of projects. As a matter of fact, thank you for the books. The KeyCAD books. I've been going through those and trying to pick up on KeyCAD. So need to start doing some boards.
That's awesome. I'm also itching to do some boards. I haven't done any for like 25 years now. And things were a lot different in that day. They were expensive. You had to order 100 at a time, even for a small project.
Right.
And now you can get 2 from China for $5. It's
great. The funny thing is I can see on my shelf back here, I have a little box from Archer. Do you remember those guys? And it's a printed circuit kit, making your own circuit boards, with the acids and everything.
Oh, yeah.
It's a little box I've never opened. I went through a few of those.
I can only imagine the environmental implications.
Yeah.
I've never etched my own circuit board, so what would you do with the acid and that sort of thing?
Yeah, I remember back in the day that was the biggest problem is what do you do with it? I didn't know what to do with it. And so so I didn't do too many boards because I didn't like all the chemicals.
Yeah.
And so but I did do a few. I don't even remember what I did with it. I know I didn't pour it down the sink because I was afraid of damaging plumbing.
Yeah.
So, but yeah, I'm glad today that we can get online and get boards and get them within a week or two.
Yeah.
So
once in the 90s, I wasn't much of a cooker, but I decided to cook once, and I had cooking oil left over, and I didn't know what to do with it. I also didn't want to pour it down the drain, so I phoned the company that made the oil, and they also had no idea. It just wasn't a thing to worry about.
That's pretty funny. Yeah, I guess today, even changing the oil in the car, I used to do that stuff. And what do you do with the oil? And I think today you can take it down to a local store that does oil changes and they'll take it. But
yeah,
that's when I started taking my car in, just because I was like, geez, you can't just pour it into the ground. So didn't know what to do with it.
Well, but, what I do with old technology, electronics that are not longer useful, I keep it because I'm a hoarder. The family's going to have a hard time when I'm gone.
Right. Yeah. I've had the same problem. I've got lots of test equipment that I've, accrued over the years. And so, but I've told my wife and myself that I'm going to start getting rid of it this year. A lot of it.
Okay.
Because
Good.
I need to make room.
Well, at least you've got an incentive. I don't have a wife, so that's a problem. I've got no discipline over here.
Right. Yeah, that helps have, her keeping me on track.
Yeah.
But there's just so many projects you can put on boards today. I started some power supply designs, and actually when I started this channel, that was my key focus, was going to try to teach power supply design. But I didn't get a lot of views on that. Whenever people would send me a multimeter to review, and people loved those. I thought, well, give the people what they want. But there's also people that keep asking me about, hey, when's that project going to start up again? So I do have it, and I've been working in the background a lot. And so I've got some other projects to get out of the way. Some of these, there's actually a lot of work, that goes in these projects. Like some of them, I do a lot of testing on the cables and the other components in the test to prove that the test setup is good. And then I start doing the testing. And so I'm in that phase right now where I'm testing some Class D amplifiers. I have kind of a stack of them like everywhere. And I'm going to start, and there's some Class A Bs and Class A amps as well. And then I've got some old Macintosh MC30s over here, and I am going to show those. And one of them I started updating years ago. I replaced the capacitors in it with the new poly caps. And I remember talking to an audiophile back then, because I was in an audio group. I was living in North Carolina and actually teaching school at a community college, industrial electronics. And a guy said, "Oh, geez, how could you change those caps out with those new polys?" I'm like, well, if the engineers back then had these available, they would have used them, And so it's like, I don't want to use the old technology just because they did. I mean, they would have used the new caps for sure. And so, because no one's designing new stuff today using old parts, So it didn't make sense for me to keep it original. It's like, I'm going to improve on it. And so, I actually had a lot of audio equipment that I also kind of built my system over the years. And I had it in storage, and we had kids. And when we moved to our new house, I just kept thinking like, oh, wait, kids get a little older before I bring this stuff in. And then it ended up getting, somebody else wanted it more than me. Somebody broke into my storage and took it.
Oh, no.
So, yeah. And then I paid for that storage for probably 2 more, maybe 3 more years, just because I couldn't bring myself to go to the storage to clean it out. I just wanted to put it out of my mind, Then I finally got tired of making it, because the payments kept going up and up. I'm like, okay, it's time to clean out my gear. But that's where a lot of my test gear was too. And they left that, and there's some valuable stuff there. Well, to me, but they left all that stuff. So I do have a lot of test gear as well. A lot of cool stuff, I think, but it's just taking space. So, but some of the new test gear, we might talk about later, I guess, but this red patella thing, that's something that's new. That I guess the whole idea of that was to replace a lot of the gear, so you didn't need a big bench full of gear. And so I think that's pretty interesting device. And I've been kind of studying that, and I'm going to start doing some videos on that too, and kind of show value of a device like that. So there's never an end to the kind of videos you can do. You get into a project and you realize, wow, I need to do this video, like just showing capacitors, impedance of capacitors, And then the audiophile type capacitors that people claim that are so great. It's like I want to do all these comparisons to see if there really is any value in the more expensive capacitors. So yeah. There's just never, some people, they talk about that they run out of ideas on YouTube, but it's like, geez, my list just keeps growing.
Mine too, and I'm not doing them, but maybe after retirement I'll have the time to dig into passion projects.
Right.
I mean, like that computer behind me, it was made in 1981, still works fine, so I don't need to recap it. But if I were to upgrade it, the upgrades would be inside. I want the outside to look pristine, just like the original.
Right.
45 years. And shall we talk about oscilloscopes? I'll
Sure.
just bring up my window here. I love this bow plot that you did.
Oh,
I did not know that amplifiers went way above 20,000 kilohertz these days. So I'm wondering, look at that. What was that, about 75K, 55K? Yeah, it's a logarithmic graph. So I think your frequency response was up to 55K, which is great, but we were just talking about we can only hear up to 12K. Is there any purpose of an amplifier going up to that frequency?
Well, I guess there's a couple trade-offs and making the bandwidth smaller. Like, I guess ideally you could go out to 20K, maybe just beyond, and then just cut straight off. But with a lot of amplifiers, especially the old analog amplifiers, Class A, Class AB, you have to have a filter and you have to roll it off. And if you roll off too quick, you get this resonant bump. And so that's not good, and so usually they just have a nice roll off. And so you don't want, when people see a graph and they see it's already started rolling off at 20K, they're like, whoa, that's not, I want it flat at 20K, even though they can't hear it probably. So you end up, having this wide bandwidth. And so, I think the problem is if you do have some noise or something that's being amplified at those frequencies, your tweeter, your speakers probably don't like that. So it's probably not a good thing to put, a signal beyond 20K. So some of the Class D amps, they have, digital filtering where they can just essentially just drop off like a brick wall. But then again, I've done some testing just recently with some of these Class Ds that also have that resonant bump. And so there's an LC filter on the output, and that filter has to be optimized for either 4 ohm or 8 ohm, whatever the output impedance is. It's part of the filter. And, if it's optimized for 4 ohms, then at 8 ohms, you get this, this amplification. And I don't think that's a good thing. So when people just only test out 20K, they don't see that because it happens around 50 or 60K is what I've been seeing. And so, if they just graph out to 20K, they don't know that, well, they're graphing the part that you can hear, or at least, within the human hearing range, but they're not graphing the part that the electronics, your speakers see. And so I want to see the whole picture.
Well,
so
speaking of speakers, this is something I've wondered for a while. When they graph speaker frequencies, it's never smooth. There's always bobs and bumps there. I see this one drops off significantly after 20K. I don't know if that's a coincidence, but why the hills? Do you know?
Yeah, it's interesting because with the speakers, they're trying to get this 4 or 8 ohm or 6 ohm impedance, across the thing. So if you have 2 or 3 drivers, a tweeter, mid-range, and a woofer, a bass speaker, then you have these crossovers, these filters. And so as each one has a band, it passes a certain band, then it drops out and the other one picks up, they cross over, and then you can get these little bumps between them because they're not going to be perfect. And as people try to make them more perfect, they get more wiggles, but smaller wiggles. And so, but yeah, it's really, and then also the drivers themselves. So speakers are a very interesting animal, and I think that's where the audio, most of the audio differences come from is the speakers. And it's funny when people talk about cables and all this other stuff, where it's this, like what you showed, that graph. I mean, you can look at graphs of electronic stuff and it doesn't look anything like that. So the distortions and all that stuff mostly comes from the speaker itself.
Yeah, and you're speaking my language, people talking about cables. I used to install television antennas, so I knew the importance of having a good antenna up on the roof. If you had a weak signal, get a bigger antenna. And then you would go to these audiophile stores, or where they'd have home theaters, and they would sell gold-plated cables for the connection between your VCR and your TV, as if that was going to make the huge difference. There's no substitute for metal in the sky, as they say.
Yeah, no, that's true. It's funny because I, as an engineer, and I've done lots of BMI testing, so I've been in labs where we're looking at very small signals, and I can see where the noise problems are and how we try to solve them. But yeah, as an audio guy back in the day, I would get suckered like that too. I remember when the first flat screen TVs came out, and when they started going to high def TV, I got suckered into buying one of those expensive video cables because the guys like you say, I'm like, oh yeah, that looks great. Yeah, how much is that? Oh, okay, yeah, I'll take that too. And it obviously doesn't make any difference. And especially these cables that are handling digital signals, where when you're putting those RF cables up, I mean, that's a whole nother animal. That's a different beast. But with the digital cables, as long as the receiving end picks up the signals that, the little clock cycles it's supposed to be looking for, it doesn't care if there's a slight bit of noise on them. It says, oh, I just transitioned, that's a 1. It doesn't matter if it's a clean one or a dirty one. It's like, that's a 1. That's why it's digital. It's either one level or the other. And so, these people that think that USB cables and things like that make a difference, it could be that maybe they might have better connectors. Maybe they've spent a little bit, but you can buy cables with really nice connectors for just a little bit more. You don't have to, take that big leap and spend. I've got cables that, cost hundreds of dollars. I put one right here because I test with it sometimes. This is a Kimber cable. And I met Kimber actually back when I was in college, and Ray Kimber, and they're beautiful cables. Now, does this make any sense? One of the signals is traveling on a silver wire. The other one's traveling on copper. It makes no sense, but it sounds cool. And people pay a few $100s for one of those. So, I mean, a pair of those. So, yeah, it gets kind of crazy.
I've seen all
I'll get people challenging me on YouTube, and well, you just have to listen to them, and that's the whole thing. Is people? It's like I call it the belief system. They just want to believe in it.
Yeah. This has been a very interesting conversation. Nearly half an hour has flown by. I should acknowledge our audience. They're here. Frank DeHart says he can hear up to 9K5, and that's it. So yeah, it's like when you're a music lover and you can't hear all the music. That sucks. Now, Frank is one of our regular viewers, and he often arrives first. But Debbie Hansen, she got here almost 2 hours early and said it will be phenomenal. Can't wait. And then we've got Switzerland, Fremantle, Australia, South Fremantle, Belgium, Albuquerque, New Mexico, not too far from you in Utah, Eddie.
Right.
Hungary, the Netherlands, France, Thailand. Someone who says finally 2 sunny days in a row in Boston. But okay, greetings to everyone. I don't want to waste the time, the precious time I have with Eddie. Baltic Lab, a 2-time previous guest on the show, says hi, everyone. But there was something interesting about throwing that acid away. Said something about pouring baking soda into it until it stopped fizzing and it was neutral pH, then it could go down the drain.
Okay. See, there you go.
It might be okay for the drain. I'm not sure if it's okay for the water system or the oceans. but I don't know. I'm not an expert.
Yeah, that's the thing. Chemistry is not my thing, but that does make sense where you could at least neutralize some of the effects and make things safer.
Yeah.
Yeah. So that's
an interesting
cool.
question from Hansel Williams. No audio buff here, but don't squarish audio like percussive sounds at say 5 kilohertz plus need higher harmonics to get the edges sharp?
So that's interesting. You know, music, it's not, you don't get square waves, right? They're sinusoidal. And so you don't get harmonics until you break up a wave, and then it turns into, like, you build a square wave with a whole bunch of harmonics. And then that becomes a sine wave, but I mean, if you could put all the harmonics back together. So percussion sounds, they do have harmonics caused by the instrument, and so, yeah, you want to hear that stuff. And that's why I think some of the tests, they use 2 tones to see how things bounce against each other. But yeah, testing amplifiers, that's still a really interesting thing. 5K you hear really well, and Frank hears up to 8K. He probably still hears most of the music, because most of the music's probably less than 8K, the actual music.
That's a good point. There was this Nyquist theory that you need to sample digitally at double the highest frequency that you want to play back. Now, I understand why, but like you say, the audio is sinusoidal, so you're never going to recreate that 20 kilohertz if you're sampling at 40 kilohertz. There will be square waves then. Fortunately, I can't hear that high, so it won't bug me.
Right. Yeah, exactly. And that's why they have to sample faster. And if you notice, if you do the math on most oscilloscopes, it's actually 2.5 times. Because if you sample twice, imagine you sample each time the waveform crosses 0, you're always going to see just a flat line. So if you try to skew those samples off a little bit, then there's this other distortion that happens. So they go, oh, well, what if we sample 2.5 times? Now you're never going to be on the 0 line all the time. And so that's why most oscilloscopes, if you do the math, and some scopes will have even higher sampling rate, and people might think, oh, well, gosh, I'm going to buy that scope because it's 5 gigs instead of 1 gig. And the thing is once you get above that 2.5, the benefit is very little. And I've reached out to some scope companies asking them about that, and they agree that, once you get past that Nyquist thing, about 2.5 samples. And I forget the guy's name, but there's actually a guy that came up with that theory, and then for some reason Nyquist got it was named after him. But I think he put some math together, and he was approaching from another angle. But there's a guy before him that actually came up with the with the actual theory of how many how to sample and how to get an accurate reconstruction of a wave. So I need to get those names down so I can tell people. But
you're very big on note taking, I see. You don't rely on fancy graphics. You've actually got the notebook there when you're evaluating things. And you've gone through a lot of oscilloscopes. Do you own these all? Or do you borrow some of them to do reviews? And
so that one I bought, that was the one that I researched. And then the one I'm pointing at now is this one back here, the GW Instec. And I bought that one second. So those 2 I bought. And then after that, I started getting people sending to me for free to evaluate. And so, and then I had a viewer send me one that, he wanted me to give away. And it's kind of funny because I've done these multimeter giveaways, and I tried to give it a scope away one time, and I tell people, hey, send me an email. And I get very few people send me emails. So one time I was going to give a multimeter away, and I said, hey, the first one that sends me an email, well, I think that one I was going to raffle up, but anyway, I had like 5 people send me an email. So I just found 5 meters and sent each one a meter. Wow. It's funny that, and then there's been a couple times where I've had a lot of people send me emails, but most of the time I'll get one or none. And so I think that's interesting. That I think people just feel like, oh, there's too many people are going to send responses, so I'm not going to even try.
Yeah, I ran a contest once with Elektor, and I got an email like 2 weeks later saying, I know I'm too late, but I just want to check if I'm correct. Guy, you're the only entry.
Yeah, it's funny. I think it's just that thing where you just feel like, what's the point? There's 1,000 people ahead of me. And so they just don't. Yeah. And more so when I think when I was a smaller channel, I got more people responding. And yeah, these days.
That's interesting.
So now, yeah, the scopes, some people, I've even heard them on YouTube where they say they got to do this review and then they're going to return the device. And somebody asked me to do that because they wanted to see me review this other brand scope. And I don't feel good about that because then the company, Amazon, has to sell it as an open box or as a used box. And it's like, if I order something knowing I'm just going to return it, that doesn't seem right. So yeah. So everything I review is either most of it is stuff that recently has been things people send me. And I still buy things because I'm like, I want that meter. And I don't know how to get one, from the company. So I just go buy it. But yeah. So, and then I get some things from I was just looking for evaluation boards. I get some things, well, this is actually an amplifier board I bought. So yeah, I still thank you to my patrons, my YouTube members, because they help pay for all this stuff. But yeah, I bought this guy and I still need to do the video on that one. And I have some power supplies around here that I bought, but I get some evaluation boards from Texas Instruments. And I think most of the ones I've been given have been from them. And I've considered buying a couple because there's some things I want to review. I want to present, show people how these things work, these power supplies. And so they're great for that. And so I'm looking at all these tubs. They're kind of clear tubs so I can see what's in them, but
I got lots of those too.
But I do have a project. It's a power supply that it's really can be used for a lot of different applications. And, when the power comes in off your AC socket, you go through an EMI filter, and then the first section, which is going to be an active power factor correction circuit, and then into an LLC converter. And I want to do that for an audio amplifier, but you can make small changes and use it for practically anything you want. And I think I'm going to do it around 500 watts for that design. I've been kind of waffling around deciding, should I do 1,000 or 500? But I think I'm going to do the first one a little bit lower wattage, make it a little bit easier for others to follow along and build one, and try to make the boards available at one of the PCB houses so they can just go order them. So I haven't landed on any particular company yet, but I am going to use KeyCAD.
Yeah,
I've used a bunch of different softwares, but since this one's free, and it seems to be over the last few years, especially, they've done huge upgrades on the software. And so, yeah, so I want to kind of show people how an engineer approaches a PCB design versus some of the other stuff I've seen on YouTube, where I saw a guy one time design a board without a schematic. And I'm like, wait. And then, of course, it didn't work. He forgot the ground. And it's so funny, the return, whatever, and it's so funny because you just automatically think in your head, oh yeah, return's there. And like, even when you draw a schematic, everybody draws those little triangles for the ground. Oh, they're just magically going to be connected. And in his head, I guess he was thinking about all the connections and forgot about the return. But yeah, that's why the importance of doing a schematic, even for a simple circuit, even when you only have a few components, just do a simple schematic. But
yeah, I've made mistakes even with the schematic.
Yeah, of course.
Or sometimes I've designed a board based on a switch that I had in stock, and it worked great, the prototype, but now I couldn't get more of those switches. They weren't configured that way anymore. So I just had to do some hand wiring.
Right. Yeah, today it's important to, when you design things, I think it's always been, but especially today, to make sure you go on DigiKey, and see if there's parts available, because you might design around a part and realize, oh shoot, there's a 3-month lead time for me to get that part. And so, yeah, it's good to verify those parts are in stock. And a few years ago, when we were having problems with getting parts and stuff, you could wait a year for a part. So people were redesigning boards just because of the availability of parts.
Absolutely.
So, but yeah, oscilloscopes, we were talking about scopes. God, they've come so far these days. Like with the 12-bit scopes, finally, I've been crying for those. Like, how come we're still stuck at 8 bits? And so now all of a sudden they're coming out, and there's some that are, reasonably priced. And so we're living in a good time for test equipment. Test equipment's very affordable. Now, some people point out to me that it's all from China and they don't like that. It's like, well, what do you do? Even the the American companies are having their stuff made in China. So it's like, if you buy it through an American company, from what I understand, when I worked with the company that we worked with the plant in China that they owned, they have to hire a local politician to, give them an office. And so, when you put up a company there to build your products, you're also employing a politician and, as well as all the employees. So I don't know how that's any more American than just buying a Chinese product just directly from the Chinese.
Yeah. Well, we won't delve too much into politics with the whole tariff situation and supply chain economics, but in any event, NET says you have a cool electronics lab, which indeed you do. Are those frequency counters behind you?
I do have, I have some generators, and this is an audio analyzer, but some of the generators also have frequency counters in them. And the oscilloscopes, well, this scope right here, this is a loaner. Actually, so some of this stuff's just loaned to me, like this Unity scope. This is a loaner I need to send back pretty soon. But that has a pretty good frequency counter, actually. Because it's a 12-bit scope and it has a really good digital input. So they actually kind of claim that it's a frequency counter. But yeah, I used to have, and I'm kind of wondering if I still have it. I used to have a really nice frequency counter, and but I never used it, So
you're not really a digital guy.
Yeah. So I have some digital stuff. The Patea, I guess their idea is that you can use it for a lot of different things. So it's pretty interesting how small this thing is and how powerful it is. But I think this is 14-bit. So we'll see more videos with that.
Yeah, we're hoping to get Red Patea on a show to do a webinar sometime in the future.
Oh, that's great.
And speaking of which, the author of the KiCad books that you have behind you, Peter Delmaris, he's done a webinar with us. I'll drop the link in the chat.
Oh, good.
So
Yeah.
check that out if you want to see a bit from the author directly.
It's an easy read, you know. I mean, and it's laid out very nicely with nice pictures and stuff, but it's built in sections. So you want to learn how to use a certain part of KiCad. It does a really good job of showing how it works. So I've been kind of walking through it, and so when I started doing my board design, I've got a schematic in KiCad right now, and when I started doing the board design, that's, you know, I've already learned a lot from it, so should go pretty smooth.
Yeah.
Should
Hopefully.
Yeah.
So now, what is the highest sinusoidal frequency you can look at based on the equipment that you've got there?
This loaner scope can go to 500 meg, and then other than that, my scopes are, I think, 200 meg. I think they're all 200 meg. And you know, it's funny because I always try to think of who needs something more than even 10 meg, you know, and I think so much of the electronic work is done at lower frequencies. Now, the guys that are into the digital stuff, especially video, and that, you know, the high speed digital stuff, you know, they might need some higher frequencies. Generally, you need a scope that's 4 times faster than whatever the frequency is you're looking at, so that it can, you know, those harmonics we're talking about, so it can take some of those things and rebuild a square wave. Otherwise, the square wave starts looking sinusoidal. And so, yeah. So, but yeah, so that's not super high frequency. The noise level, I think, on these scopes is getting down there too, especially with the 12-bit scopes. So, yeah, it's all improving. And I've got an Omicron Lab device that can do, I forget the frequency it can do right now, but it goes pretty high in frequency, and it can give me graphs for the impedance of capacitors, inductors, and that, and do feedback loops. And so it's pretty capable, and I want to show that more as I'm doing this power supply design. That'll come out. As a matter of fact, I got some speaker crossovers I want to, I've been getting a lot of questions about them. So I think I want to design one of those, or reverse engineer one, to show why it was built a certain way, and put the components on this Omicron so I can show what that looks like. And, you know, some people will take a measurement of an inductor or a capacitor and say, okay, it's 5, millihenries. But they may not realize that once you put current through it and get some power going across it, and that's a different measurement. And so, I want to show those kind of things to show that, actually I have to test or get the value of the component under the power conditions it's going to be running in. And so, it's pretty crazy. When you build a lab, you want a scope, power supply, multimeter, and then you need resistors, loads. And I'm looking at these active loads, and you can get those really inexpensively now, where it's so cool that you can build a lab for not a lot of money these days. And it's people refer to them as hobby labs or whatever. It's like, well, these labs are pretty, the labs I worked in 10, 15, 20 years ago, well, you could have called those hobby labs maybe. So, the equipment today, it's becoming pretty sophisticated, and you're getting it for low cost. And so electronics. And so that's where, your magazine, I remember back in the day, you had some competition out there, and it seems like you guys survived, where a lot of the magazines I used to read are gone. And a lot of the hobbyists, I guess, dropped out. But I feel like it's coming back now. And I think it's because, we're talking about printed circuit boards. You can get boards made relatively inexpensive. and you can buy test equipment. You can buy a really nice meter for not a lot of money. And in fact, you can get the little handheld scope meters that are inexpensive, relatively inexpensive. You got a scope and a multimeter. So yeah, back in the day, that would have been awesome if I had one of those when I started. But yeah, it's yeah.
I've told the story before of not having access to an oscilloscope when I was younger, much too expensive, or a logic analyzer, but we just used to persevere and make do with what we had. And I ended up learning how to program the PC parallel ports to sample digitally.
Oh, wow.
It could do up to like 400 kilohertz at most. But, you know, it showed me what was going on in the circuit, which I needed to know. It was a lot of work, but it was a great education rather than just having all the expensive luxuries right off the bat.
Wow. Yeah. I mean, with the stuff, you know, the Arduinos and stuff out today, you would have loved that stuff back then.
Yeah. Still do.
Yeah, exactly. Yeah, it's fun to build things. Yeah, there's another project I have in mind that I want to show how maybe you can do something simply and do it with the different, come at a different angle and get something that's actually useful, you know, so yeah, I got some projects that is for do-it-yourselfers. I want to start doing more projects. So I haven't done a lot, and I want to start doing more projects. So that's kind of going to be a new thing for, you know, as this year goes on, we'll see more projects coming out. And so,
awesome. Yeah.
And then also, well, so I have an amplifier I'm looking at over here on a stack of equipment, and that's an amplifier I built. Is my first audio amplifier that I was really proud of. You know, it's like I made it. I think I built that when I was still in college, but there's a guy named Erno Borbelli, and I think, I'm not sure what country he was from, but I want to say Norway or something like that. But he had a really interesting design. And it's interesting to me that no one has built those designs. Like, I don't see his name around, and people are building amplifiers from other people. Well, Nelson Pass is still here, but there's other guys that, you know, people are building amplifiers from, and they're copying their circuits and, you know, building them. But I think his circuits were really cool. And so that's a project I want to do. I want to kind of basically reverse engineer that and make it a board so people can build those. And it's based on FETs, you know, it's all FET design. So it's kind of an interesting spin. But, you know, back in the day, I thought it sounded great, you know, and
yep.
I used this distortion analyzer back here, this Krone height, and I improved this expensive amplifier I had, and I went in there, had some JFETs in there and the feedback, and I could hear this sound, and I thought, I'm going to get rid of that. So I beefed up the feedback loop, and I got the distortion really low. Then when my wife came home, I said, hey, what do you think of this? And she's like, what'd you do? I'm like,
sorry, she said what?
She's like, what'd you do? Like, you ruined it, you know? And I'm like, no, it sounds, and that's that expectation bias, you know, that placebo effect. I was thinking, oh no, isn't it so much, because I could see it was way better. The distortion numbers were really low. And I'm like, wait, hold on a second. I only did one channel. So I played the other channel. She goes, yeah, that sounds good. And I go, okay, point at which speaker sounds better. And she goes, that one. And I'm like, oh, geez. And then I sat there and listened. Once she said that, it kind of, all of a sudden I started hearing it. I'm like, she's right. It sounded like a leash was on the one that I had beefed up the feedback loop to drop the THD. Yeah. And it tested real well, but yeah, listening to it sounded bad. Now, if I would have done a Bodhi plot, I probably would have saw that I dropped it off. Maybe it was rounding off at 10K or something. You know, who knows? I didn't have the Bodhi plot of it.
You need a double blind test.
Yes. Yes. People are afraid of those for some reason. I think they'd sell less cables if they if they agreed to do those.
Yeah, definitely. I just want to jump away for our giveaway. For our audience, like I said earlier, we're giving away this Elektor Audio DSP FX processor, new revision, which is right up Eddie's alley. So that's why we chose that. And to enter, all you have to do is visit the URL on your screen now. And the code word for today is DSP FX. Case doesn't matter. So good luck to everyone watching. Quite a few of you. And
yeah, that looks like a fun project. I've been looking at your store. You guys have some, you guys actually do, I think you do a really nice job on your pricing too, because it's meant for, it kind of just reminds me of the old electronic magazines where, you have to mail in your check to get your thing back before.
Well, I had to do an international money order back in 1990 to get a PCB from Elektor. Back then, Elektor was only selling the boards for the projects, but now they sell entire kits. Evolved quite a bit.
When I was in North Carolina, I was teaching, and I went there, and I thought I saw a teaching job. My wife was going to go to orthodontic school. That was my ex-wife now, but she went to orthodontic school in North Carolina. So I had to find a job, and I saw a teaching job, and I go sit down, and there's a table full of people in conference room, and they're all wearing suits. And they said, okay, so how would you go about starting an industrial electronics program? And I thought I was just going to go there and be a teacher and kind of have an easy job for we're going to be there for 3 years. I'm like sitting there like, start an industrial electronics, I'm like, I go, well, I guess, I said, that's a great question. I guess I'd write a curriculum, go find some books and get some equipment. And they're like, yeah, that sounds about right. So that's how I got that job. That was a fun job. That was, but yeah, North Carolina was a fun place. I met a lot of people in the electronics field. They have those ham fests where you go buy stuff, kind of like a yard sale. But that back in the day, that was fun back then. All the electronics you could do and the kits you could buy, and then it kind of dwindled away. But now I see it coming back, like I say. So I think, and with your kits that you guys are doing, I don't know how long you've had your store. I don't know if I knew you had a store. I just remember looking at the magazine all the time.
Yeah, well, I know I used to buy products from the magazine itself. Obviously, that evolved into the .com world.
Yeah. I was trying to think of an article I just read from you guys not too long ago, but you have some good authors too. I don't know where you get them from, if they're on staff, if they're people in the field, but
it's a combination.
We
have an Elektor Labs site. Let me show that to you. Bring that up on screen. So on our website, we do have our own authors, but we also have a section here for community projects, which we call Elektor Labs. And anybody can come here and put in an idea. And if we like it, we might hit you up and get you to write an article for us.
Okay.
So, elektormagazine.com/labs. A lot of interesting stuff here. And I'm glad we have this because, like you say, a lot of talent out there. And maybe we wouldn't know about them if we didn't encourage people to come onto the website and give us some ideas, some great ideas.
What's interesting is those boards, when you look at them, they look professionally done. Where I remember back in the day when we used to buy things from Electronics World or whatever, Popular Electronics, they looked like kids.
Yeah. Those magazines are so expensive that I couldn't bring myself to throw them away from the 90s because they were imports over here. So I still have them in boxes somewhere. Yeah,
I have some boxes over here for my storage center that I pulled out last summer, and I haven't gone through them yet, but I think I might have some Elektor magazines because I kept them all too. So I can't wait to get in those boxes. I want to see some of the old publications. When I was in North Carolina, there's a I started doing audio stuff, and I thought I was going to do audio design, and that I kind of had a plan, and I was writing articles to the Audio Amateur, and they sold kits. And so if they liked my amplifier design, I thought we'd kit it up and all that. But then I ended up moving back to Utah, and I moved around a lot. And every time I move, it'd take a while for me to settle in and try to get my projects going back again. And so I just never picked that up again. You know, I can say that about a lot of projects. So
before I move to an interesting comment here, I just want to highlight this page. This is the Elektor-submission-page, which I'll ask the control room to put on the screen shortly. This helps people understand how to submit articles and products and projects and videos. So to our audience watching, feel free to visit this and learn how you could become an Elektor author.
Oh, that's really neat.
Now,
and that's what's great is this YouTube thing is connected us to the world. You know, I get people from all kinds of countries, you know, that are writing in, and I just think that's really cool that you can actually reach so many people everywhere. So
yeah, it used to be amazing and awe-inspiring to me that I could pick up the phone and make a very expensive phone call to someone on the other side of the world, and now here I am chatting casually to you over in Utah while I'm in South Africa.
Yeah, wow, that's crazy. Yeah, the old ham radios sitting there at night with your antenna up there trying to pick up somebody, trying to see how far across the world you could reach. And it's really neat now that you can just get on and see a comment pop up from some guy in Bangladesh or something.
Yeah,
it's crazy.
It's an interesting comment here. If I'm dealing strictly audio, 100 megahertz is good enough. Still use my Tektronix 2236. Do you mean megahertz or kilohertz? Why would you need 100 megahertz for audio?
Yeah. And that's the thing is, like, it used to be people were happy with their 10 meg, 20 meg scopes. That was kind of how they started back in the day. Now it seems like, 100 is just a common one, but I guess 50 megahertz are available. But 100 megahertz is plenty good. And when digital scopes first came out, I remember I had a Tektronix 2465, and I love that thing. I think that was a 300 meg scope. And then I got the 2430, which is their digital scope. And I was so happy with that thing, but I could see flaws in it. So I kept my 2465. I'm like, the digital ones aren't replacing the audio ones anytime soon. But today, I think the digital scopes, I like them better now because you can save and store things. And I really love the digital scopes today. But 100 megahertz is plenty good for audio. You're going to get all those harmonics and everything.
Well, I wonder if you could help me. I brought some toys for show and tell today, and I can't even get 30 megahertz on mine. Could you just maybe tell me what I'm doing wrong here? Show you my scopes over there. Don't often see behind the camera. There we go. So, could you tell me why I'm not getting 25 megahertz on this?
Wow, is that a CRT?
Yeah, exactly. That's why it's so deep.
Yeah, which model is that? That's Tektronix.
It's a Kenwood CS4025.
Okay. Yeah.
And then, just as a little surprise for show and tell, you mentioned Tektronix, Joseph. Here we've got a Tektronix waveform monitor for video.
Oh, nice. That's the TV signal.
And a vector scope
as well.
Wow. So right now it's got that signal, and you see it's all blue except for some writing over here. And if you take a close look, let's get rid of the light here. This is the blue part. These little dots here represent that PR1.
That's really neat.
and it's running from this VCR here. I had to bring all the old tech out.
Oh yeah.
But if I press play and get some color bars, then
Oh wow.
you can see the color bars. Those
That
are the
is
different
so
colors
cool.
over there. The vector scope is going crazy, and it's cut to black now. So you can see the signal is black. These are the syncs pulses, but there's still a color burst. But when the actual show starts, surprise, surprise, you won't guess what show it is.
Oh my, that's cool.
So I thought I would show that off a bit, bring some
Yeah.
toys for show and tell.
So
Do
the
you
scope,
have any CRTs?
I do actually. It's what is it? I've got, it's funny because I've got some old stuff. I've got a CRT scope over there. I forget which one it is. I've got a Heathkit device. This is a transistor tester, and I can hear something moving around inside, but I got a bunch of these Heathkit devices. Remember Heathkit?
Yeah.
And but my first scope was a Heathkit, and then when I was getting more serious, and I saved some money, then I bought a Kikasui, and I think it was a 60 meg scope, and and I thought, man, I've got everything I'll ever need.
Those were the days.
Yeah.
You mentioned the CRTs being deep. I can do a demonstration on that, because this vector scope, I've unplugged it because I don't want to get a shock. Waveform monitor still running, but I can pull this out of the rack.
Oh wow.
Look how deep that CRT goes.
That's
to the back.
Yeah, that, back in the day when they made those CRTs, there's so much art that went into like that card and how it's shielded there, and the way they showed the CRT.
Yeah.
There's so much going on there. That was like the magic with Tektronix and HP, held. And they were beautiful CRTs. And then they had the delayed phosphor,
Yeah.
kind of the first memory on the scope.
But this is close to delayed.
Yeah, so that scope, so it's not triggering fast enough. The horizontal sweep won't.
Yeah, I don't have a trigger or any inputs. Luckily the waveform monitor picks up the sync pulses itself and sorts out the triggering. But for a scope, you need to provide the trigger signal. Yeah,
the old analog scopes, people that were working at television repair shops they'd have to get the scope that had that special trigger for the, the NTSC or whatever. And
yeah,
and then the ones in Europe that everybody else uses, they would have to get that so that the scope you could get a good trigger like you're getting on that scope. And these days, I've been looking at that lately, and I've been noticing that a lot of the scopes, since I've been thinking about it, they're on all the scopes I've seen, but I don't know if they're on all the scopes. So now I'm thinking, like, I got to go back and look at all my scopes and see if there's that. I do have a leader scanner, that'll put out all the waveforms, and a television generator, and so it'll do the color bars and does a whole bunch of stuff. I forget what but yeah, that's sitting over there too. So I might have to put it up on the bench so I can, when I'm showing scopes, I can show that cool waveform you have.
Yeah, that's great. Baltic Labs says the whole name of the theorem is the Nyquist-Shannon theorem. I think that's Claude Shannon.
Thank you. Yeah, Shannon was the guy, I think, that originated the math, and then Nyquist focused it in on one aspect or something. I forget his part, but yeah, the Shannon. Yeah, thank you. That was the guy's name I was trying to think of. So it's nice that they're giving him credit there.
Yeah, well, I always learned about Claude Shannon when it came to information transfer and theories of noise and that sort of thing.
Yeah, I guess the guy was he a mathematician?
I'm
He
not
did
sure.
a lot of different things from what I understand. I think he is noted for a lot of things, and you know, one of those smart guys that we name things after.
Yeah, exactly. Someone wants to know from you what the best type of capacitor for replacement in amps or old test equipment. Are you replacing in the power supplies or elsewhere?
Yeah, good question. The power supplies are one of the first places the caps usually dry out and die. And the aluminum electrolytic caps, there are good ones. And so when you're replacing aluminum electrolytics, in a lot of cases, you have to, especially if they're large, you have to replace them with the same, with aluminum electrolytic. Same, but it doesn't have to be exactly the same technology. I mean, there's not a big change in aluminum caps over the years, but there are better quality ones. And usually you can go by how many hours they say they're good for. A lot of them are 1,000 hours or 2,000. But if you get the ones that say 4,000 or 10,000 hours, then those are higher quality capacitors. And if you get one that's rated 105 C versus 85, then they're going to work better and longer. And so, and then also the voltage rating. So I worked for an audio company for a short minute, and and I had to take a huge pay cut to work for these guys. And they wanted me to use this capacitor that was rated just a few volts over the voltage we were putting on it. I think we were putting 400 volts on it, and they wanted 380, and they wanted me to use a 400 volt cap because that was the size that fit. And I'm like, that doesn't work. You got to derate them. And they're like, oh no, that's what we've always done. I'm like, and that was their answer to everything. When I raised a question, I go, well, we've always done it that way. And I'm like, oh geez. It turned out that during my design review, the owner of the company wanted to sit in and listen to his new engineer do his review. And he asked, well, how come you're not derating those caps better? He goes, I think you should go 450 volt caps. And I just had to I couldn't say, well, because he told me to. So I just sat there and went, but yeah, so you want to get, it's good to only use 70% of the rating of the capacitor. So you want to have that 30% voltage margin and headroom. And yeah, the temperature is a good thing too. But yeah, other than that, in other places in the circuit, you can use polypropylene caps to replace old Mylar or other types of poly caps that were cheaper. And so I heard a guy one day say, oh, they didn't use cheap capacitors because they were cheap. They just use them because that was what they needed for the application. I'm like, no, they use them because they're cheap. Guaranteed. I mean, yeah. So going back to North Carolina, there's a German company that was put up there, Rotorstein, and they made awesome poly caps and resistors. And Dell resistors bought them, and then Vishay, I think it was Vishay, bought them. So under Vishay, you can find Dell resistors, and they're probably Rotorstein. I think they still show the name. So if you look for the name Rotorstein, the poly caps, that's what the audio guys, the audiophiles back in the day were buying. And now today there's these other esoteric names, and they're spending way more money than Rotorsteiners were. But today you can get polypropylene caps for relatively inexpensive, and wasn't that, prices just come down on some of this technology. But if you're an audiophile, you still have to spend the money. So they still find a way to come up with another cap.
Yeah, some way of doing it.
Right.
Do you remember ways to enhance CD audio when it's all digital, and they had these fraud things where you could put a rubber sleeve around the CD, or you could color it in with a green marker, and people swore that it was warmer on the top ends. But when some technical guys tried this stuff with an oscilloscope or a logic meter straight from the output of the laser. It was the exact same ones and zeros.
Yeah, that doesn't surprise me. Back in the day when Philips were selling real expensive CD players for audio, I bought a Magnavox because they're the same company essentially, and they had the same electronics in them. And I think back then most of the chips were either Sony chips or Philips chips, and so the only difference was the audio, the analog front end, and so. But the Philips player that I was like, it was just so expensive I couldn't afford it. But what they're saying is they had separate power supplies for every part of the circuit, for the motor and all that. And as a power guy, I was like, that makes sense. Why you'd separate, okay, the noisy motor, put that over here, and the analog section, keep that quiet, and the digital section, keep it, have different grounds for each one. And so that made sense to me. And I like, okay, that's not snake oil. That's, I don't know if it made a difference in the sound, but it makes sense, technically that it could make a difference. But,
especially in analog.
Right.
But with digital, I tried explaining to a friend of mine that makes no difference. The exact same numbers are coming out of the machine. And he said, I'm not listening to numbers, I'm listening to music.
Yeah, it's funny because like you're talking about broadcasting messages when you broadcast video, and I'm sitting there watching it, and it's coming across 10 megabits, I'm like, okay, if I get 6 mega, the video is awesome. Anything less than that, you start seeing things happen to the screen, latency errors and things like that. But as soon as you come up to say 6 meg, all that goes away. It looks perfect. From 6 to 10, there's no difference. And so when you have a digital problem, you can see it. You can hear it for sure. And so, the whole digital thing is crazy how now, and what's going to be funny is somebody's going to come out. Well, I'm sure they've already done it with some expensive fiber optic cable,
Oh yeah,
like
I'm sure it's already been done.
Yeah. The engineers, we sit there and joke because it's like I was talking to a guy and we're like, man, if we didn't have any ethics, God, just think the money we could make. We could say we work for this defense contractor. Well, we used to, but now we make so much money we don't have to. But we work for them. I mean, we got this name behind us, and we know what we're doing in audio. We make the best cable there is, and but I feel like you have to be a crook to do that.
Certainly unethical. I've never been comfortable with promising what is not true or not likely to be true in any way.
Yeah.
Eddie, we've gone over the hour, but I've
been
told by my team that they don't mind sticking around a bit longer. How do you feel about taking a couple more questions?
Yeah, I'm happy to. You can tell I just talk. So
yeah, I'm just worried I'm keeping you from work or something.
No, I'll go in a few minutes late and work a little bit late. Yeah.
So then there's a question. If you're working with like 2G and 5G stuff, what do you suggest as a DIYer for tabletop?
2G and 5G studios or studies?
Yeah.
Oh, are they talking? Okay.
So if you're working at those really high frequencies,
yeah, I'm wondering, are they talking to RF? Are they talking communications?
I think so, yeah.
Yeah, then, I mean, that's,
2 gig and 5 gig. It's a whole different bowl of fish.
It's different equipment, yeah. It depends on what end of it you're looking at. If you're looking at the RF end, you're going to need RF equipment. If you're looking at the digital side, then, you're going to, need more. That's where the high-speed digital stuff comes in. Laying out circuit boards, for instance, all that stuff it gets more expensive when you get into the where you actually have to look at those signals, or you're designing a circuit board to that, that's more challenging. So, but if you're on the RF side, it's a little bit easier because that kind of stuff's been done for a long time. So
yeah.
But
Well,
yeah, that's expensive.
It won't be cheap, but that's the question.
Right.
That's the answer. Going back to environmental, in Belgium, they take their, what is it, iron chloride to the container park where they, somebody help me out, which acid is that, where they treat all dangerous substances?
Is that something chloride maybe? I don't know. Yeah, that's great. I understand in Europe that there's that does that ring a bell? I think they call it where wherever you buy a product, they have to accept it, to return it, recycle it. In the US, there's places you can take your batteries, and I think anybody selling oil will take your oil. But yeah, I'm not sure about some of these chemicals where you would take them to. I think if they're selling the product, they're supposed to recycle it.
Actually, I did say iron chloride, but Baltic Labs just jogged my memory. I think they used to call it ferrochloride for making circuit boards. As a comment from Chris Cox, I have name amps full of Rothstein electrolytics, all leaky now. Had to replace them all. Sometimes you get a bad batch.
Well, and if they're leaking, I'm wondering if he's talking about aluminum electrolytics. Right. Capacitors, aluminum electrolytics, from the day they build them, they start aging because they're breathing. You know, they have that vent. It's really the only component on the board that's designed to fail, right? I mean, well, it has a lifetime on it, where almost everything else will last indefinitely. I've got some old multimeters from Radio Shack from 40 years ago, probably, and they still work just fine. And but yeah, the aluminum electrolytic capacitors, they start to age, and that's where the recap came from. You know, people want to keep their audio gear, and it's funny that industry didn't derate capacitors well enough, so they overheat, and with temperature and ripple current, they're going to wear out faster. And there's actually an equation for that'll tell you how long you life, and it's a reliability thing that you have to do for like most standards in that. And the thing is, though, is what that equation doesn't tell you is that there is a drop dead date. It doesn't tell you about the dry out period. It tells you how you can wear them out faster, but it doesn't say, for instance, tires, if they sit on a shelf, they're in 10 years, they're not any good, you know. But if you put them on a car and they're like, oh, they're good for 20,000 miles or 30,000 miles. But if you sit them on a shelf, they're still going to go die. But that's not in the equation, you know.
Yeah, perhaps it's got to do with the theory of relativity. If you're moving, you age slower.
There you go.
When did you first realize amplifier total harmonic distortion could be heard and so really existed?
Geez, I think the film industry, you know, when they started making film and audio, I think they've been studying audio for a long time and understood harmonics from probably when they first had oscilloscopes. And yeah, so I think that THD's been around that's a good question. I don't know when, you know, they first realized that, but I think it's been probably even before scopes were a thing. And so it was probably, a theory well before they could measure it.
Yeah. And two comments, both saying the same thing. Neutralizing is with baking soda is fine, but you still have the copper ions, which are still poisonous, which Baltic Lab makes the same point. We have someone very late to the party, Micronai7. Please tell me how you came up with that username. I'm very curious. But he says, working, LOL. Nice to see Eddie on the channel.
Yeah, it's I was trying to think of a name, and I thought, I want to teach power electronics. I want to teach how to do, power supply design, switching power supplies, but I want to keep it easy, keep it simple. I'm like, oh, keep it simple, stupid. But my wife says, no, keep it simple, silly. And I'm like, okay, that works too. So that's kind of how it came out. And so, yeah.
And did you ever go by any other name, or that's the first one you came up with?
That was the first one I came up with. And I think it was the first one. And I searched and it was available. So I'm like, okay, that works. I'll do that. Awesome. So, and then I called it audio instead of power supply design. I actually thought about calling it power supply design, but I thought, no, I know eventually I'm going to do audio stuff, and which it's all related, and so, and then I've been trying to push this new naming convention, people call them linear power supplies and audio amplifiers. I'm like, they're not linear because they're not regulating them. They're low frequency switchers. The diodes are commutating, they're turning on and off. So it's switching. If you look at the currents, you get current spikes. And so when you do a block diagram for a power supply, when I present my design to, for design review, I show that first block and I just show that I usually just call it a bridge rectifier capacitor, the volt capacitor. I don't have a name for it. I just say this is what it is by components. And then the other things, a buck boost or Ford converter or LLC or whatever kind of converter. And so when I was doing this channel, I'm like, how come we've never named that section? That's a low frequency switcher. So I just started calling low frequency switcher, and some people are starting to catch on.
I did see a question earlier. Two interesting questions. Somebody asked about how to get started with SMPS design.
Yeah, that's a great question. I got really lucky. I went to California. My wife, now ex-wife, she was going to dental school there. And so I went to UCLA and was working for Aerostronics. And I got a job as an intern to do their CAD, to do their to do some CAD work, but also the main job was going to work for the systems engineers and write the requirements document. And they thought it'd take me all summer, and I was just chomping from our work. I was done with it. And I was like, give me something more. And this consultant came on, and he was from Israel, and he was like he was a gee whiz guy in power supplies. He designed pretty much every power supply that was in the Gulf War that flew in planes for the flight control systems aspect. And so he normally had a sidekick that he'd bring, and this time he didn't have one. And he asked if Aerostronics could provide him some legs, so do his grunt work. And so I'm like, yeah, I'll do it. And so he interviewed me, and then I started working for him. Worked for him for 18 months. So learned a lot from him, and learned about EMI design and just, how to do power supply design. So that's kind of how it got kicked off. And I was I love it because it does have some digital stuff too. We have some logic gates and stuff where we're looking at things. And when I was putting that part of the circuit board together, I went home and did a Karnoff map and simplified the circuit. I love that stuff. And so I took it into him, and I go, hey, Avi, what do you think of this? We can get rid of a chip if we did it this way. And here's the Karnoff maps I did. He's like, I'm not real good at digital stuff. He goes, oh, that looks great. Thanks. I was afraid, I didn't want to, I didn't know how he was going to take it. This little intern telling this guy that was like, when this general manager, whatever, came into the lab, he was like, Mr. Avi, this guy was not a real pleasant guy, but when he saw Avi, he was like, oh, Mr. Avi, what can we do for you? Is everything going good? So I thought he was like, he was a big shot, but he was a really nice guy and taught me a lot. So I got lucky. I've been lucky in my career. I've had worked for some really good defense companies, and what's nice about it is they have lots of work, lots of projects going on at any one time. So that's one thing I like about defense is there's just tons of work to do. So they always need a power supply guy.
Well, John has a comment that an amplifier is just a modulated power supply.
Yes, Mr. John, you're right. It is. And Class D amps, back when I was learning about power, when I was working with this guy, I was still an audiophile, I thought I was. And so I thought, God, I wonder if I could design an amplifier based on the switching power supply. I thought, that's crazy. Nobody would go for that. And, lo and behold, Class Ds pop up everywhere. So, but yeah, he's absolutely right. That's why audio amplifiers and power supplies go so well together, because essentially a power supply is just an audio amplifier, right? Just putting out one signal. Yeah. I actually have a power supply on the space station, International Space Station. I was working for this. I was VP of this little company, real small company. It's like 6 of us or something. And the owner marketed this power supply as being able to do anything, essentially. And so the Germans, they contacted us and said, hey, can this power supply put out a sine wave signal from, this voltage range at this frequency? I'm like, wow, that's really interesting. I wonder if it can. So I took all the capacitors out of the output, except for one small poly cap or something. And sure enough, it could. And so we're like, yep, can. We had a little microprocessor on it that we could program. So they gave us a signal, and we would change the output based on the signal they put in. So yeah, it actually worked really well. And so they were using it for some testing they're doing on the German side of the International Space Station. So I put my daughter's initials on that circuit board, her birthday.
Oh. I always want to do something artistic on a circuit board as well. So well done on that.
Yeah.
And that makes you a good father, which is a great segue to the question we've got here. If this extra time on the show is a bonus for Father's Day tomorrow in Germany.
Oh,
Did
wow.
not know it's Father's Day tomorrow in Germany, but now I know. Happy Father's Day to all the German fathers out there.
Yes, happy Father's Day. That's awesome. That's cool.
With that, I think we'll bring it to a close now. It's been a long time. I haven't even touched the water. It's been an interesting conversation. And I want to thank everyone for joining us. The extra time is not for Father's Day. It's because Eddie had extra time, and the director of the show also had extra time. So thank you guys for your time and spending extra time with that. And that about wraps it up. A huge thank you to Eddie for sharing his insights on power design, amplifier testing, and separating audio effects from fiction. And to the person who asked how to get started with SMPS, RF, all of those things, a good start would be KISS Analog YouTube channel. And
there you go.
Drop the link in the comments. So check it out there. Just look up KISS Analog on YouTube. There's plenty there. So separating audio effects from fiction. And if you enjoy today's show, check out his channel. And remember to enter the giveaway for the Elektor Audio DSP FX processor. Mm-hmm. Visit the giveaway page, the code word again, DSP FX. And if you missed any part of this, because it was a very interesting and in-depth conversation, or want to revisit, the recording is available on our YouTube channel. Just elektor.tv in the URL bar will get you there. And while you're there, please give us a like and subscribe, as Eddie will always say on his videos as well. So thanks once again, Eddie.
Yeah, thank you. I really enjoyed it. That was fun.
And thanks to our audience. Thanks for joining us, and we'll see you next time on Elektor Engineering Insights.
All right. Thanks, guys.